you ever use an app and just think, wow, how did they do that? Especially with some of the wild AI features we see today? Well, it's not just one person. It's a whole team of specialists. Today, we're going to pull back the curtain and show you exactly who does what to take an idea and turn it into a real intelligent system. Let's get into it.
Right, so here's the big question. You have that light bulb moment, that aha idea for a game-changing AI product. But then what? What's the actual path from that spark of an idea to something that millions of people can use? That's the journey we're going to map out for you today. Okay, so first things first. Before a single line of code gets written, you need a plan. A blueprint, right? Every incredible building needs an architect, and it's the exact same thing in AI. So let's meet the first key player, the architect, the person who lays the entire foundation. So what is an AI solutions architect? Honestly, you can think of them as a translator. They speak two languages fluently. The language of business, revenue, goals, customer needs, and the language of deep tech. Their whole job is to bridge that gap, to make sure the amazing tech that gets built is actually solving a real-world problem and not just a science project. And look at what their mission boils down to. It's not about using the coolest new model. No, it's all about business impact. First, solve a real problem someone is having. Second, reduce risk. That could be technical risk, security risk, you name it. And third, make the company money faster. It's practical, it's strategic, and it's absolutely crucial. All right, the blueprint is approved. We know what we're building and why. Now we need to actually invent the core technology, the magic, the brains of the whole operation. This is where the pure innovation happens, and it brings us to our next role. And this really breaks it down perfectly. You've got these two key innovators working together. The architect is all about the big picture, the what and the why. They hand off that blueprint to the research engineer, whose entire world is the how. How do we actually build this thing? It's a classic partnership. The deep learning research engineer, this is such a cool hybrid role. They're basically part scientist and part hardcore engineer. One minute, they're reading a brand new mind-bending research paper on arXiv, which is, the go-to place for all the latest academic preprints. The next minute, they're in the code, trying to turn that wild theory into something that actually runs. And their daily grind? It's pretty much the scientific method on steroids. They'll read the latest research, form a hypothesis like, hey, what if we tried this crazy idea? Then they'll code up an experiment, often using tools like PyTorch or JAX, and run it on clusters of powerful GPUs, those superpowered chips that are perfect for all the heavy math and AI. Then they analyze the results, learn, and do it all over again, constantly pushing for better and better performance. Okay, so check this out. We've got the architect's blueprint, and now we have a working AI model from the research engineer. But it's a prototype. It's like a hand-built concept car. It's amazing, but you can't mass produce it. So now we need to build the factory, the assembly line that can crank this thing out reliably for millions of users. And this is where the ML systems engineer comes in. If the researcher built the boutique engine, this person builds the whole automated factory around it. They are the absolute masters of making things scalable, reliable, and robust. Their job is to take that fragile experimental prototype and turn it into an industrial strength service. So, what's job one for them? Building a rock-solid foundation of quality. That starts with what's called a CI pipeline. That stands for continuous integration. Just think of it as an automated quality control system. Every time a developer makes a change, this pipeline automatically runs checks and tests. It's like having an inspector at every single station on the assembly line, catching problems the second they happen. But that's just the start. The quality control gets even deeper. They build layers of testing. You've got unit tests, which check the tiniest little pieces of code, then contract and integration tests, which make sure all the different parts work together correctly, and finally, end-to-end tests, which basically simulate a real user clicking through the whole app. It's this deep, multi-layered approach that guarantees the thing just works. So now we have this amazing, automated, quality-checked AI factory ready to go. Great! But where do we put it? Where does it live? For virtually every modern tech product today, the answer is simple: the cloud. It's the only way to get the kind of global scale and flexibility you need. And the cloud isn't just one thing. There are different flavors. You've got IaaS, or infrastructure as a service, which is like renting raw land and building your factory from the ground up. Total control, but a lot of work.
Then there's PaaS, Platform as a Service, where they give you the building and you just bring in your machinery. Less work, a bit less control. And finally, SaaS, Software as a Service, where you don't build anything, you just use the final product. Think Gmail or Salesforce. It's all a trade-off between control and convenience. So why does everyone do this? Why the cloud? I mean, it's a total game changer. Instead of spending millions on servers you might not even use, you just pay for what you need when you need it. The classic example is a streaming service dropping a huge new show. The demand goes through the roof for one weekend. With the cloud, they can instantly scale up to handle millions of viewers, and then scale right back down on Monday. That kind of elasticity just wasn't possible before. It lets you move fast and experiment without betting the farm. All right, we've walked through the whole assembly line. We've met the key players, from the architect to the engineer. But let's bring it back to you. How do you fit into this picture? What does a career in this world actually look like?
The cool thing is, these aren't just dead-end jobs. There are clear paths for growth. Just look at this example for a research engineer. You start as an intern, just learning the ropes. Then you're a junior, owning a small piece of a model. Before you know it, you're a senior engineer, setting the research direction for a whole team. And eventually, you can become a principal engineer, influencing the strategy for the entire organization. Every role we've talked about has a ladder just like this.
Yeah, let's talk about the money, because these skills are in insanely high demand. These are some typical salary ranges in US tech hubs. You can see the progression is pretty incredible. As you grow your skills and take on more responsibility, the financial rewards grow right alongside. We're talking serious earning potential here. But here's maybe the most important piece of advice for anyone in this field. The long-term goal isn't just to be the best coder. It's to evolve from being a builder into a strategic advisor. The people who become truly indispensable are the ones who can use their deep technical knowledge to give the business insights nobody else can see. That's where the real power is. So there you have it. That's the playbook for taking an idea and turning it into a world-class AI product. You've met the architect, the researcher, the systems engineer. You've seen the whole process. So the only question left for you is, which one of those roles sounds like you? Which chapter are you going to write? Thanks for joining me.